All right, y'all. Today we're gonna be tapping into a part two of what we did yesterday. Yesterday was a premiere, so it was pre-recorded. Today is gonna be strictly live. We'll see if we can get about 2 or 3 hours in of just strict designing and uh, tackling some things like the servo mount and uh, the shock holes for the shocks and the swing arms. So let's jump into it, y'all. So this is where we left off at, where we designed um, the swing arm mounts, a little bit of the frame, and a rough estimate size of what the rim is going to be like. This is just a rough estimate. It's not going to be the exact size of the rim, but we'll see once we get that far. Um, So first thing we want to tackle where we left off at was creating that whole distance for the shots. And there are so many different sizes of shots that you could use for these applications. Let's go here. I'll shut that body off real quick. This inner hole here. Um, what we want to do is create a gap big enough for our shocks to go down inside of there and to have a little bit of extra play. So I have 3 different sizes that I mapped up. And I'm dealing in inches if this is your first time seeing me. I like to deal with inches because it's a lot easier for me to gather. It kind of feels like a 100% ratio number system. So um, it's easier for me to think about. But for shocks, the max width would be 0.75, and I'm guessing the thinnest that I have is the blue in here, which would be a 0.5. So with that being said, and 0.5 would be a half inch if you didn't know for those in terms of what I'm talking about. So we'll verify that here. Also, we're going to be creating a way to mount that, whether it be just a hole going through here, or us creating like a notch that adds height to these swing arms. It's just a lot that you can do with these type of applications. Also, we need to have that good width in between, so when we're fully extended or fully closed, we'll be able to clear the spring areas. All right, so first thing I'm gonna do is going back to the body width. We want to make sure that we got the best distance that we can get between these body mounts. Let me see. We want to make sure that we get the best gapping and spacing between the body and should I say the wheel placement, because if it doesn't bottom out all the way, that kind of defeats the purpose of the lowrider effect. So it needs to be able to bottom all the way out, but also it needs to have enough space on those swing arms to give us a good height when it's fully extended. So that's what we want to focus on today. Let me see here. All right. All right, let's see. how do I want to do this? I guess we could start by stripping everything back. I'm going to be measuring out. I also measured my length that I have for my shocks that I did my last build on. I started out with I think it was like a 74, a point 74, 74, yeah, 0.74 length shock. And then I downsized. And the reason I downsized, I went down to a point 0.5, or not, I'm sorry about that. My shock length was like a 2.5 inch, right? Or that's what I'm working with now, but it was like a 3 inch shock at first. And when you have the length of your shocks, it has to, like, when you're totally bottomed out, the top of your body, only you only have so much space between being bottomed out and the top of your frame. And with your servos, you only have so far that those mounts could lean, or that your shocks can lean inward. So you have to compensate for where the servos are, like the servo. um Man, I don't know why I'm tripping over my words so much today. I didn't have any coffee today. That's probably what it is. Your servo horns, right? So let me take y'all over to the workbench. I probably could just show y'all exactly what I'm talking about a whole lot more than um what I'm trying to do here. All right, check this out. So this would be like ride height, right? Totally out. This would be around ride height for us. But when we have this thing totally bottomed out, these portions here sometimes extend out further than the axle, or the top of the chassis. So it'll bite into the top of the body. When these bite into the top of the body, you don't get a full bottom out. So depending on how high or what your length is on your shocks is going to play a good part in you getting the right height, for your servos or whatever. Now your servos, with them being as close as they are, you only have so much tolerance between the length of this rod here and the height where it mounts to the shock. So that's what we gotta pay attention to the most, because our boy Derek, he went with the standard size servos. On this system here, this is a 8 inch wheelbase length. We are losing 2 inches of that play because our wheelbase on his vehicle is 6 inches. So our what we're compensating for now is that this part here is going to be closer together in order for us to get bottomed out totally. So having the shorter struts and the shorter shocks gives us a better placement for these servo horns, so that they don't hit the top of the roof. So that's what we're talking about here. So that's what I mean by um, that clearance that we have to have. So those servos, they have to be in the right place for us to do what we need to do. So let's get back over here. Back over here. All right. All right, so our height, and he said he's probably gonna go with like a 54 um millimeter spring, which is a little shorter than a 2.5 spring. If he goes that route, then we should be in a good ball game, a good area to make this happen. So I'm gonna do is, and this is just to get a rough estimate of how much space we're gonna have, is open that body up that we had before, that middle flat plane that we had. Remember that? We want to bring that center floor back, right? Remember the center floor? That center floor is 1.6, which doesn't, all right, so I think I need to remap this body real quick, because I think my scale is slightly short or slightly shy of the 6-inch wheelbase that we was talking about. Or am I mistaken? No, that's right. We're lining right up at 3. So that's right. That's right. Sometimes you have to say, sometimes you second guess yourself because of the way the numbers look like they're laying in. But all right, let's do this. So what I want to do is get a reference of the height of that vehicle. So once I'm designing at the center point here, we can do what we need to do. Okay. All right. Let's get the right height here. So I am going to do, let's get rid of the swing arms for a second. Knuckle. Let's see the body. I should have got rid of all of these other bodies that I'm not using. So I don't have to keep on scrolling down the list. About 100 bodies that are just in here. I'm not gonna do that individually. I should have did that off camera. I don't know why I don't think about this stuff when I'm not live. But let's do this. So we'll turn the body off for a second. We're not going to keep this box. We're just going to line it up so we can have a reference point here. We're going to draw onto that base that we were at before. Come on. There we go. All right. So we're going to draw right into this base. We can use a square for this. And this doesn't have to be perfect. This is just giving us a rough estimate of the height, kind of where the servo mount is going to meet the shock. Right, so now we have that. We're going to close this out. I'll come over here. We're going to extrude this up as high as we can get it with that body being on. And we're going to get rid of that swing arm on the top. Top swing arm. Let's get rid of the bottom swing arm too. So anything that that will stick and become a part of this. We want to get rid of it. So when we're extruding, it doesn't add on and join as one part. And that's something that like early on you gotta get into a habit of, because you don't want that to happen. You know, you don't want to be designing and then all of a sudden you merge a piece that don't need to be merged. All right, so we got that. We're going to extrude that. And right now we just want to get the height. I'm trying to get as close as I can get to this body without, you know, there being any hassles or things going on with it. So we can see we got 2 inches of play in here. Right now the shocks that I have, I think were 2.5. Yeah, I think they're 2.5. So with that being 2.5, we're gonna have to lean those inward for that to, you know, make sense. So we have this, right? We can go ahead and bring our situation back with the swing arms, right? Zoom in on that. We can get rid of that. We're gonna bring the swing arms back in. Knuckle and the swing arms, right? All right. So we can actually go lower than this base here. That base just gives us a reference of how everything will sit. But off from center hole, we're gonna possibly bring it from this part here, like straight down the middle of the lower swing arm, and then we're trying to measure up whatever that 2.5 or whatever is. Now we know this line here is the middle of the vehicle, so the servo mount is the servo horns are not going to give us that play. You know, the servo horns are going to sit somewhere in this area here like this from the center, and then they're going to cant out in this direction here. But that's the thing too. If we have to turn those servos sideways, that will give us a little more space to bring them lower if we need to bring them lower as well. Let's see. I can draw. Let's draw onto this arm here. I want to see what my I want to see. Oh no, that's extrude. I want to draw. Okay, we got a little bit of lag going on here today. I'm not a fan of lag. Not a fan of lag at all. All right. So we're gonna draw from the bottom swing arm. We'll get over to it. Let's do a measurement from that, from this point here. Actually, let's draw a line. That would be like the best way to grab the center line. Okay. We create a center line, go from center hole to center hole. Hit the OK button. And now with a regular drawing, we'll be able to get a center point here. See, without it, we wouldn't have been able to get to that center point. Let's take away the floor for a second so it doesn't interfere with us getting an exact match. So right here is center point of that nut or that swing arm. And then we want to measure out which mine was 2.5 inches, which is not gonna cut it. Cause like I can already tell now we're way past the bed or the body. 2.5, 2.5. Yeah, we're way past where we need to be. Let's bring that body back. Oh, never mind. Never mind. It felt like it was like it was like wasn't within that tolerance, but somehow that worked out. But now that would lead for us to our servo rods would have to be right at the top of what we're sitting in. So I think we might be all right. This might actually work, guys. This might actually work. So we'll map it out. Let's map it out and let's see where it takes us. We might even could get this thing to sit straight. And that is, in my opinion, the best way to have your servos to be like an L, straight flat, right off of the spring. So you have a lot more travel room for that push. And then you don't have to worry about your spring being at an angle. Just a second, guys. I gotta go grab something quick. Yep. Yeah, you need? Yeah. So I gotta put off the water. Then all right, sorry about that, guys. All right, so what I was describing was uh the less travel space that we use on the actuation of the spring, the more we don't have to worry about the we don't have to worry about running into any problems with binding when the when your spring is moving up and down. Now we want it to move up like vertically as much as possible and not have that lean sideways like I was talking about. But sometimes you end up having to have a little tilt to it in order to make it work or make it fit. Um, but because he's probably gonna go with a 54 millimeter spring. If he can find one, that would be awesome. That it'll give us a whole lot more range for the servo arms to do their job, you know. Sometimes you can have too much length in the spring and then you have to cut back on the length in the servo horn. And that just gives you more torque. You will get to your height, your ride height position faster with a shorter horn. The longer the horn, the more time it's going to take to bottom and fully extend out. But you'll get the height in, so you just got to find that healthy medium between the two. Um, so let's go and cut these circles out. I'm up to all my circles and all my hole sizes, so I wouldn't have to go back and do it later. Um, that hole size is going to be a 0.3, right? That spacing in between there is going to be a 0.3. The actual hole, I think it was a like a 0.15. That was actually smaller than that. So we're gonna go 0.12. We're gonna keep them 0.12 for the holes, like just like how we did these ones over here. I think these might have been 0.13. All right, so let's take that floor back out. All right, that makes me feel a lot better to see that and to know that we are within our tolerance. Sometimes you can second guess the measurements, man, and you jack them up. Right, so that hole is at a 0.12, so we can always go a 0.13 to make a nice wiggle room. The outer structure of that whole area would be a 0.3, right? Well, 0.4. That would be like the outer case that holds the shaft for the shocks. Yeah, so I don't think we're gonna have a problem with this at all. All right, let's finish that up real quick. We're gonna extrude straight through this thing. I may even want to move it over. I want this to be more on the flat side and not specifically down the middle. So let's do that before we extrude this. So we'll go double tap back into that drawing. Let's say from our center. We're just gonna move that hole if we can get it to move for us. So 0.2 maybe. I'm curious as to why I wouldn't. Maybe because I have that. Would it move? Yeah. Sometimes you can have restrictions and restraints on your parts by having them anchored to other rods and things like that. And when that happens, it won't let you move a part. So sometimes you gotta look for those staple lines and triangles and circles with the holes, with the lines through them. All of those create a solid setup for you to not be able to move it. All right, let me finish that. Actually, let's get rid of this line too. We don't need this line necessarily. We just wanted that for our measurement. So we're going to extrude that. And feel free to get in the comments too, It's all right. I'll be checking for that too. If y'all got any questions or comments. I like to chop these symmetrically because like I said, it handles those areas that you can't see though, that skin surface that you can't see. but it'll still be there and it'll come out in your prints sometimes. So I always cut past the holes in the surface, just to make sure that we don't end up with that. So with this, I do want to pick a side, and one of these holes is going to be bigger than the other one. So for this application, we'll do like a one side will have uh it'll have a encased layer where the bolt head actually fits in flush with the side, and then the opposite side will do a bigger hole for a brass insert. A brass insert, I usually go in like a 0.15 to anywhere between a 0.15 and a 0.2, right? This just gives us it gives us space to press that insert in there. So one side will be bigger, and we'll maintain consistency with that and on the same side of whatever we're doing. So even here, you know, if I choose a side, I want all of my inserts to be on the same side. So I'll push those holes out to that distance. So like right now we're at 0.13. I just have to move them out a 0.05 or a point 0.1. No, 0.01. Because I think that if I'm not mistaken, it's moving it from the halfway point. What we said, 0.01. Yeah, 0.01 makes it a 0.15 now, because we have to cut it in half. You know, that whenever we're working with those circles, it's not going to give us the exact number. 0.01 on a negative. I also got to pay attention to that, how the numbers change, you know, according to that negative or the positive, like depending on which direction the arrow is pointing. Sometimes you can cut the size down rather than extend it, and you just have to pay attention to it. All right, so we have that side set. On this side is going to be that bolt head, and to minimize it on your workflow, sometimes it's easier to map it all out at one time, and then you'll already have it drawn out. But sometimes when I'm talking, I don't I don't I don't leave room to remember that type of stuff. So I'll have a nut already out usually for that purpose, so I can just take my measurements off of those like during real time. Even though I've worked with these so much, um, sometimes for whatever reason your brain don't want to hold on to all the measurements. Even in making notes. So we have an N3 with the flat head bolt, you know, flat head side. These are going to fit down inside of the hole and sit flush with the swing arms. And I like to do this for everything I'm doing. Now it could be a 0.21, 0.22 is good, 0.23 if you can get a 0.23. Will give you a nice space to work with. 0.23, gives us a nice little space, right? And then we just gonna push this surface in whatever the thickness of that head is, and add a little bit to it. So it's coming in at a point 118. We'll add to that, so we'll go up 0.13. 0.13 will give us a nice push inward. We'll get a nice little bite steel out of this. And because the arrow is facing out, we're gonna go with a negative number. So it'll be negative 0.13. Right. And if it's red, it's cutting. If it's blue, it's adding and joining together. So from that top side, that's how much we'll end up cutting into that surface. But it's gonna yield to a clean finish, like when we get ready to print it and mount it. It's gonna have a really nice look to it. Also, it adds a little stability too for the boat head to not want to bind and turn and twist outside of the part. So I mean, there's a couple of things that it does for, the durability of the parts too. So that what we did there, we would have to do the same thing for these parts here. Sometimes when we do that, we would end up having to add meat around these areas here, and that will cause us to end up with like a nice bow or something like that with these parts. I mean, the sky is the limit for like designing how to make a part look nice and keep that strength to it as well. But that's what we want. So we got that. Probably could have did, like I said, I would have minimized my workflow if I'd have did these circles here in the same setting rather than having to keep on going back and forth with it. That's what I should have did. Let's see. So what I should have did, I'm gonna do now. 0.23. Yeah, I'm gonna do it now. I should have did it all at once. And that's how you stretch out your time and waste other people's time. There and there. And what we said that push in was, it was a 0.13. So negative 0.13. Okay, was the same ordeal. Okay. Now the outer structure of that little part right there, it don't necessarily have to be thick, but if you're like, strict about it having to be a certain type of way or be a certain type of thickness around all of the surfaces, then this is not a problem to extend out or make it thicker. You just add another circle, extrude it out, and then smooth it down. That would be how you would handle that situation. And you have the space to be able to do it too, so it wouldn't be a problem. So that we got that bottom swing arm together. It's got enough space to handle our swing, to handle our what you call it, our shock. So in between here is a 0.5. We actually have more space in between here than we actually need because the spacer that we have is only 0.3 thick. And we're measuring from this hole here from the side. So the thickness of this portion here is what would be down inside of there, which is a 0.3. We have us having a 0.5 gives us a lot of wiggle room and a lot of play um, for if the binding or fully extended or fully lowered um, causes the shaft of the or the cylinder of the shock to end up having to slide through here a little bit. You know, like say if we did end up with that being at a 45-degree angle, remember we was talking about with the shock having to come in at an angle sometimes. With it being at an angle, the shock cylinder is going to go past the arm a little bit on either direction. And if we make it too tight, that cylinder won't be able to fit. You'll end up with a bind in right there. So that's why we leave that space. But if you're gonna end up with that shock being upright, then that's something you don't have to worry about. And that area can be as tight as you want it to be. But I mean, there are other ways to work around that as well, because this hole doesn't have to be flush with these holes as well. We could have extended that hole. We could have put that hole above here where it doesn't interfere with the inside of that mount at all. You know, like say if we wanted this to be even more durable, we take this hole, we bring it up above the plate, the swing arm plate, and we just make this whole area solid. Kind of like what I did on my other swing arm here. How I designed this swing arm here, where it's flush, the hole sits above. You know, dropping that hole down inside of the arm just gives it a more space for to bottom out. And especially because we're working with a slightly smaller scale than a 1 to 10 scale. So, you know, all of those, that math plays a huge part, and you'll see it later on when you get ready to put the things together. And you'll be thinking that you have enough space for these things to fit, and then it just somehow just all of a sudden something's hitting, you know, so you'll be looking at your car and you'll be like, what is hitting that's not causing it to go all the way down? And it'll be something like this. Like that's a huge benefit of the hole being down here versus being up here. I think we lose about a half inch if we take it from here and put it here. We lose about a half inch in play. So something to just consider and think about, like when you're designing. But also, if you need this to be stronger, you know, like I said, um, you know, create another thickness layer here, and then you know, fill it out. You know, which would kind of look cool. It would kind of look cool to do something like that. But we'll keep it here. This will be, you know, our Mach 1 version of what the swing arm would be, and then if we have to redesign or go into a 0.2 version of the swing arm, then we'll get there. Another thing we can do is also design out the shock. Like if we wanted to see it in real time, we can actually design one, you know, and have it to sit in there so we can get a better understanding of how it's gonna fit together. Um, the next thing I want to do though, next thing I want to tackle is where those servos are going to sit. So in order for us to get there, we're gonna have to bring in the frame again. So we know this top arm here is not going to be connected to the spring at all, right? And we're tracking that, right? The no swing arm is going to or this top swing arm is not going to touch the spring at all. With that being said, this has to be attached to something, right? Whether it be the servo mount or just the frame. Now I would prefer to have it attached like to the frame to where it's not it's kind of out of the way of everything else that we're gonna have going on with the servos and stuff. But also, it's gonna save space to design that mount to be attached to the servo mount, or the servo mount to be attached to uh, the frame. So it's kind of like you have to do both at the same time. And so because we probably want to tie them in together, we want to take and I was looking at this inside of the body, and I want to use the top side of this, so I'm probably going to end up bringing this area down a little bit so that we can get that this portion here on the top side of things. So because we see where how much clearance we have now, this is a lot of clearance to have. We're about double, you know, what the height of this is already. And I don't think we'll get to all the way in here. So I think it's safe to say that we can bring it down a 0.5. And what is bringing it down a 0.5, um, we can use that top side rail for our screws to mount. And then we can have like this whole swing system that comes down here. And that would be where the servos sit inside. But also, excuse me, one thing to point out too, um, is that the servos are not going to be sitting down in between um, the body, like the middle, like because we don't have that space. Now, if it was an 8-inch width, we'd have that space, but because we don't have that space to work with, those servos are going to have to sit either in front or behind um, this setup here. So with the servos being setting out here, um, they're going to have to be on the top side of where this swing, this top side of this swing arm here. So I'm thinking we went standard size. Let me grab a servo so I can do a real reference and map out of this. All right, an even faster way. So I have here a servo mount that I designed for the rear of the last build that I did. This would be sitting flat with the servos sitting flat. This is probably the direction we're going to end up going. But if not this direction, uh, we'll stack them side by side, which are going to come in here like that with these holes. So either direction, I think either direction will fit because we have so much play. This bracket here comes in at 2.25 on the height. And then if we can't get that, we can come in with that width because we said we got to be within 6 inches. If we drop them in on the width side, it's going to come in at 4.6. So 4 inches and 6. So that's something to consider. Both of these is something that we'll have to consider when designing this in here. Which would put, man, that servo horn, it would put the servo horn around this area here if we go flat. So the servo horn being here, the arm would extend back out this way. in order to give us a bottom out, or servo mount could be, or the servo horn could be on this side here. That might actually work. So let's design them flat first and see how this plays out for us. So based on needing this to come like a latch or whatever coming down, like a hanger, you know, where it hangs on top of these mounts here. We'll design it to come around, come down, and then the servo bottom of the servo mount would be somewhere around in this height. But so the idea is to find what the height of that servo horn would be, or where we want the servo horn to be. And then our frame would play based off of that height. So let's get rid of that drawing there. I'm still thinking like we need to drop this down. Yeah, drop that down to 0.5, and then take the top side down to 0.5 as well. Let's see if we can pull it. If we can pull it down, that'd be good. How's that measurement? Half of the distance. All right, let's do this. So let's go back into the original the original sketch and change it from there. I think that would give us we'll be able to keep this length, because I want this length to stay here with how far out we are, but I just want this portion to be lower. I think that by going back into the sketch we can accomplish that. So we just got to go find out where our sketch is here. This one here. Yeah. All right. So we had, what we want to do is offset this, right? Let's offset that. What we set by a 0.5. Was it a 0.5? Maybe a 0.5 may be too aggressive. A 0.25. If we do 0.25, or no, a 0.30, because if we can do a 0.30, then our bracket can be a 0.30. Yeah. Yeah. 0.30. Okay. So we could do a 0.30. We could take we're gonna do a just a tangent arch. Come on, don't. Sometimes if you don't get the right direction with these, they act up on you. Until I'll be forgetting to come from the flat side and then draw down to the bottom side. So it'll be that, and then also that part there is going to have to, we're going to have to cut this part here, and then cut that part there, cut that loose. All right, take that away. that away as well. So all we're doing now is offsetting what we just created that as that lower portion. We're just going to create that at a 0.5 now. This will or was it a 0.5? Why does it look like it's so much bigger than the rest of this? It was a 0.4, wasn't it? I'm trying to design a 0.5 and it's a 0.4. See how those numbers roll together on you sometimes? But yeah, there we go. So we have that. We'll close it up and we'll finish it out. Hopefully this will translate over to our new dude. So it didn't. It didn't do it. So we just go in where that sketch was that we was working on. And we just have to extrude it again. Okay. Oh, and this down here. Of course. That's why I didn't extrude out for us, because we didn't close that. So let's go back in and fix it. And this happens sometimes, man. It don't even have to be perfect. It just has to be closed so that we can get this thing to make it a shape for us. All right. So we get that shape right there. And then we got to extrude it out ourselves. So because we have moved this away, let's do this. And I don't want it to end up jacking up any of this stuff here. So we're gonna hide those. We'll do a double-sided, a two-side extrude. So this side here will attach to this area here. And then this arrow here, we'll click that arrow there. We'll attach to the opposite side. This will give us that push all the way through. Now it wants to cut. We don't want to cut, we want to join. So we'll change that setting to join. And we'll get that new thing going right there. It's always cool if you start big and then, pull your way back from that point and shrink them down if you need to shrink them down. And also it'll always be inside of your history. If you want to undo this stuff, you can, but that's why I keep it simple. Like this is simple, I don't overcomplicate it. I don't try to overcomplicate it. What we got? That swing arm. Okay. So totally bottomed out. We still gonna have a nice little space for this to bottom out. So what I'm looking at is the space between here and in here will probably be around the same height as the tire. And we're nowhere near close to this here being hitting here. So we're gonna have a good position on this. Even if we gotta move this frame inward, we can still move this frame inward as well. So we got a lot of wiggle and playroom here. So it's not going to be a problem. The thing that I wanted to get to is that top surface, right? So if we go back and we look at the body, right? We look at the body where that body sits. The top of our bracket for the servo is going to rest on top of here, which is going to be a 0.3 that's going to add to the top height. Then we'll have the screws that come in, One thing I'm curious about too is how it's going to play out. We might end up having to put the servos on this side rather than on this side. The body frame sits out here, right? Like a lot of this is going to be hollow to about this point here. So from here to here, a servo is not going to really fit in that space. Even if we go flat, we still may not get that space for that play to happen. Our servos, the width of the servo, I should have grabbed the servo anyway. Yes, sir. Yes, sir. I got you. Just a second, y'all. All right, y'all. Sorry about that. Had to take care of a little something downstairs. All right. The servo mount is point or it's 1.5, right? So it is an inch and a half plus whatever space that the horn is going to stick out. Now, I usually like the servo to be low because it just adds that bottom weight when you're doing the bounce. So I think we stay on the bottom side in front, man, but we're gonna lose that space. We're gonna lose that weight that we could put in the front side. But it's gonna be all right. I think we're gonna figure out something to make it work. So we'll put the servos on the back side here. We'll stand them upright. Yeah, I think that could work. All right. So let's create this box off of this. So we'll go back to the flat. Right. And see the beauty of having that 8 inches in the in between area though gives you room to put both servos in there. And we don't have that space anymore. Um, but then that gives us the opportunity to run our servo horn right above the joint area, and that'll give us some nice play for the actuation of the servo swings. Or to have them kind of off to the side. All right, so I was thinking about going flat at first. Let's start with this one, and let's see if we can get this to play in nicely. Hopefully it does work out. But if it don't work out, then we just go to the flat and then we do it that way. But we got to do it how we got to do it, right? We're gonna do it our way. All right, so let's bring that flat plate back. That flat plate is going to, where is it at? Center plate, right? What I want to do for that center plate though, I want to pull, let's get rid of that. The axle in the frame for a second. And the bottom swing. I'm gonna cut this plate back. Now this is just a template, but we're gonna cut it back anyway. Right, this is just gonna give us that area to play off of. Okay. So we'll actually create our servo mount based off of this area. So servo height. This is where the numbers get we're exact, like the exact measurement of the servo. So the servo clipped in here so nicely. Point 1.565, right? 1.565. So let's draw off of this. Let's draw off of this side here. Drawing off of this side here. From the top. Frame back. From this top edge here, we're going to be drawing out across here. But we're going to be drawing onto this surface. Or should I say the back surface? We're going to draw off of this swing arm surface. There's so many options here, right? And that's why I'm looking at this like this. because there's so many options to choose from how to do this. So come from this side. We do want to draw based off of this top edge here. So let's draw us a square based off of that top surface. That's going to be 0.3. This is going to be the thickness of that top layer that I was talking about, so that when we're mounting this bracket, it'll sit flush on top of that frame. This will give us that this will give us one of the most sturdy things that we can do. Inside of this would be that dimension of that servo mount. It doesn't matter what you prefer the thickness of your frame to be around your servos. I like to have them together where they're touching each other. It just makes everything more compact. But also, like, depending on how you want the weight to move the vehicle around, you can add space in between the servos. So it just depends on where you want the weight to be on the chassis, like especially when you're hitting those switches. If you have your weight expanded out far, like closer to the wheels, you'll get a more topply, a tippy toppy bounce to your left and right, or your three wheel motions. If you center your servos in the middle, you get a better control over your overall hop height and stuff like that. As far as like your vehicle wanting to turn left or turn to the right when it's hopping, that plays a huge difference. But also the weight being forward or backwards too will give you a, pop height as well. Like with it being on the back side of the wheel well, we're probably gonna add more hop height as far as the range of the hop, but we'll lose in terms of that front bounce weight, like on the rebound, on the recoil of that bounce back to the floor, we'll lose a little bit of weight on the front end. So those are things to just play around with and just think about. But also, like, when you have a compact space to fit everything in, you just have to, roll with how you can fit it in there as best as you can. But let's see. These frames that I had marked up, I think I went with 0.3s on all of these. Oh, never mind. These are 0.4s. So I guess I carried it out through the rest of the framework, the 0.39. Yeah, 0.39s and 0.35s. All right, so let's go that route then. Let's keep it kind of consistent with what we did there. Like I was saying, the servo horn, you want to kind of map it, how it's going to be. So what I'm going to do is I'm going to sandwich the servos together because we only have that 6 inches of play. I want the servo horn to actuate towards the outside, towards the frame, rather than the servo being on this side and actuating into the inside. Now we might, that's something to play around with later on. But if we can get the servo arm to horn to swing out to the outside of the vehicle, it'll be a lot easier for us to get that height range on that swing. So that's the direction I want to go with it. Servo height. I have servo arms so based off of the height. So let's bring the bottom let's bring that bottom sketch back in, or not the sketch, but the arm. So from this point here, so let's So we'll press P so we can gather this portion here. We want that to come out onto our picture, right? Or I didn't do that right. I could hit P, take off linked, and then hit that right there. There we go. So now we have this on this sketch, right? This is going to be our reference because wherever this falls, that's kind of where we want our servo horn to line up with that portion. We don't want to have too much bend away from where this is going to be. We want it to, I would prefer that this to swing inward rather than to swing to the outside. But if we can get this to swing, you know, straight up, you know, as straight as we can get it, that would be dope too. So with it being up here, from center to center, I'll do it based off of the measurement that I have, because when his measurement come in, it's going to be a lot shorter than this, and our servo is going to accommodate for that space. So based off a 2.5 center hole to hole, we'll just draw in a center line here that is 2.5, right? 2.5, that would be center height. We still should be all right as far as what that swing is going to be. This is what I was saying about being inward. See if you can't this in. Say this top rail here was the top surface of where the car body is going to rest, right? This would be bumping right at the top of that body, and this is the center hole. So if you add 0.3 to this, we would not be able to hit total bottom out, you know, status with this. Our servo would end up having to be on this side so that this could be swivel in towards the inside so that it can accommodate for that length to fit somewhere. It had to fit caddy corner rather than upright. So I mean, we might have to go that route. I didn't want to have to put them on the outside, but we might have to put them on the outside. But it's all right if we do it that way. You know, it's all right if we do it that way. I'm all right with it. All right, so let's do this. We're gonna draw out our square, right? Let's go 2.3. I'm gonna go 2.3 for these the bracket length. So that'll be from bottom side. No, that'll be top side. Let me measure this again. So we want to go from 1.565. Let me calculate this up real quick, y'all. So I want 1.565. I want to add 0.3 to top side and bottom side, plus 0.3 plus 0.3, which would give us a 2.165. total. All right, so all right, 1.865. So this height needs to be 1.865. 1.865. I always do that. 1.865. Right, and then this side here we'll just go all the way to the edge of whatever we have left here. Center. Well, I want to let me get center. That's all right. It don't want to let me have center. But it's a 1.6, I guess. I'm gonna go 1.6. No. Wrong. 865 on this side. That side 1.6. Right. This just covers the whole spectrum of what's going on here. Thickness of our servo. .93. .93. Man, let me get the servo out, man. I'm trying to do this on the fly. It's bothering my brain capacity to think right now. Let me grab a servo for the real. They came and fix it. The water thing is really something. All right, y'all. I'm sorry, man. I was supposed to grab this thing a while ago, but I didn't. So now here we are again. Okay. I got the servo. This is the servo that he's using. You know, that spec. This is a standard spec. So, and I should know these numbers by now. All of the designing I did around these. But sometimes your brain doesn't hold on to these numbers sometimes, and that's all right. All right, the servo is 1.58. Okay. I like the nice little snug fit, like for it to snap in and be um be a sturdy grab. This direction we have. When you're measuring these, make sure you're measuring off of the top and not necessarily the bottom, because the top has like a groovy lip to it sometimes. It sticks out a little further than the rest of the body. So I guess I can comfortably go at 0.8. I could do a 0.79, but you also have to consider that your 3D printer is going to not do exact measurements sometimes. So 0.8. 0.8 is that distance between here and here that we're going to end up with. So from there to this area here is going to be a 0.8. So top side 0.8. Bottom side, what do we say it was? Like a 0.15? no, 0.1585. So we'll keep it jiggy. We'll go up to 0.6. Let's do 0.61. Let's go 0.61. We're gonna do an off awkward number, 0.61. About 1.61. All right. So as you can see, now this box here is gonna be where that servo is gonna be. Now we could either have the mounting point to be specifically like a C channel that hey, take that to your room. Take it to your room. Take your room. Take it to your room. Sorry about that. Hopefully that didn't sound on the video because YouTube be striking people for having other video sounds in their in their channel, and we don't want that. We want to be able to rock. All right, well, so what I was saying is that we can make this a channel to where the servo is just the servo is held by just one side, one long side, and then have both the whole mounts that gets held onto the side of the frame, or it can be totally encased. I would prefer there to be a space to where you can get the servo out if you need to, switch it out or replace it. You can do that really easy. You don't have to worry about it getting stuck, or like these wires here. Sometimes when you make the fit exact, you won't be able to get this wire in there and through the frame. So those are things that I ran into in other designs. Like I think this was one of them. I designed basically off of the front mount where it goes through the front. Right, it clips in like that into the front. But if you're designing it to slide in through the back, it won't fit in there because the cord, it will not go through the back. This was some stuff that I had ran into issues with, like trying to design this. Like with that cord, it's such a perfect fit that you can't get it in there. Those are things to think about, because when you're trying to, do maintenance on these parts, you're going to end up having to unscrew a lot of other parts in order to get to it. So the idea was just to have it to fit flush in there, without having that hassle of trying to find that wiggle room, so with it being a C channel, you can have it mounted in to the back side. So that'd be the difference. Whether you're gonna mount it to be on the face of this, where the servo horn is only sticking out a little bit, or you're going to mount it on the back side to where your bracket is going to sit back here on the back side of those attachments. So those are things to consider, how far up your servo is going to be sitting compared to where it is going to land on this this frame here. So right now we're trying to mount based off of the front side to where it'll mount based on the front and not necessarily the back. Um, Mounting from the front gives us less space to work with on the back side. But if we can't get it to fit that way, then we'll have to go to the backside mount. And if that's the case, that having the C open gives us that space. So we'll have this C channel here for that servo to sit down in the middle. And then also we'll have, this is the, so if it sits in this vicinity here inside of this channel, we're looking for our hole to be somewhere around here for that servo mount, which would swing out to that side a little bit to give us that that pivot link right there on that for this for the shock, for the shocks. All right. So next what we want to do is let's go ahead and I gotta create a line here too for that mount. So this mount is gonna go all the way across the dash, you know. We're not gonna stop shy of there. So we're gonna go out 0.3 and then we'll carry it out the rest of the way so we can get that bottom side there. And then now we have that line going there. Now from our center point to center point, we're gonna find the center point line, and then we're gonna drop those holes in. Those holes are gonna be our mounting points. I like to sink those holes. You know, I have countersink those. Sorry about that. I like to countersink the holes on those as well, just like I did in this bracket here, just so that it gives you a nice clean area. You don't have to worry about your servo horn hanging up on those. So let's see. So this part extends out all the way from there to there, which will link to the other side. There'll be a little space in between here. The bracket will come down here and cut over as a little C channel here. And may even become a little part of this because that would be that'd be kind of dope. We'll have to see though. It's not going to be an exact. It's not gonna be exact. But I tell y'all what we're gonna do. We're gonna do something cool. Y'all gonna see. I'm not gonna say it just yet. I'm gonna play around with some design, you know, some design stuff, and we're going to make this thing pretty cool. All right, so I'm gonna extrude this out. Right, so I'm gonna finish it up. I'm gonna extrude it out, and then we'll come back into it. Or let's go back in real quick. There's one line that I left out. Yeah, one line I left out. And I thought that I drew the line on the right side, but I drew it on the wrong side. There's this line and then that one. Let's get rid of that center block real quick. Sometimes it'll be trying to snap to stuff that, so many different things that you can't really see. Let me drop the measurement here so I can see where this is going. All right, that's the measurement there. And bring them down from there, square them out. Actually, you're supposed to go all the way down. All right, now we can get rid of this here. Just like that. All right. So now y'all see what I'm saying as far as this here. We can extrude these out. We're gonna extrude out a what was the extrude? A 0.3, right? 0.3. That's a 0.28 on these brackets here, but I think we'll keep it consistent. 0.28, 0.285. Yeah. Let's go 0.3. I want to keep these numbers where they need to be, you know. Only way we could do this and kind of remember these numbers is to make them simple. I had to keep reminding myself to make things simple. Sometimes that's the hardest thing, especially when you think like a mechanic or engineer. There's always a creative way as an engineer you want to push yourself to the limit and get your creative juices flowing, right? But in doing that, you always create something that is just like, why would they do that? Especially like when you're working on cars. You go, man, whoever engineered this, man, they did a number on us because now we can't get this part off without removing the whole engine, you know? But in the time of creation, whoever that person was in their zone. It was like, yeah, we're gonna do it like this. Yeah, we're gonna kill them with this. And it's kind of like that, the vibe you get every time when you create. Yeah, I'm gonna kill them with this. Yeah, you're gonna kill them, all right. They ain't gonna be able to get that part off. They ain't gonna be able to replace it without going into a shop. All right, so we're gonna draw some more lines up. This way we're gonna draw our center lines. Um, we'll get those holes in there. And then we're gonna find the placement of this. Like we gotta find out exactly where it on the frame is going to mount and how we're going to mount it. Like there's gonna be an L shape that comes off or a T that comes off. That's going to give us the possibility of drilling two holes or having two holes to screw down to, so this part doesn't be flimsy, because we don't want that. That's just all a part of sturdy instability. So let's draw some center lines here. From there to there would be a center line. And then based off of that center line, we we're gonna draw us another center line up here. Right. Tape button. So, from that center line, we can create us another center line. Well, hold on, let's do this. Let's move this center line all the way. So, center line from there to there. 6.5. Then we can find the center of this. Right, you draw the center line off here. The reason why I'm drawing these center lines is so that I could just replicate those holes without needing to do anything extra. It's going to benefit us in the long run to find the center of that. Because we find the center of half, and then we come in here with these lines here, and then we can base how we're going to fixate these off of those areas. Also, there's a little groove inside of your servo mount or your servos where it's like a little triangle in between the holes. You have to compensate for that, compensate for that as well if you're going to mount from the front side. So we put all of that into play here. That'll be notches on the top and the bottom side for those to slide in there the way they're supposed to. So that gap .055. So 0.055 will come from the center point here and then go up here. It'll just be a slash going through the part. 0.055 to a 0.02, 0.025. All right, so go up to 0.025. Point 0.025. What am I drawing here? Oh no, it's a 0.25. That's why I'm looking like I'm thinking that it's a circle. Yeah, all up in my grill nuggets. So the 0.025, right? And then what we said that other one was 0.55. We could cut that in half pretty much. 0.055 divided by 2 gives us a 0.0275. So 0.0275 right there, then up to that right there. So said 0.0275. That's what we said. Come on, don't be thinking on us. This thing be having some random thinking going on with it. All right. And then 0.0275. Yeah. Take these two here. And we can mirror them. Just to cut down on time. Center line will be here. Right, so this whole area right here is what's going to get cut out for those center notches. Now, because we did a bottom side, we have the bottom side of that area. We can select these and we can mirror the bottom side as well. Where is it? There we go. All right, so we can mirror that, and we can mirror from this center point here, and it'll drop it down below for us. It should have, which tells us that this line is off-centered somehow. It shouldn't be off-centered, but it is for some reason. All right, so let's not do that right now then. We gotta figure out why that center line wasn't centered. Blows my mind. Blows my mind. All right. Let's draw us a new center line. And sometimes with these platforms, man, you don't know what's going on with them or why. Sometimes they don't give you the exact measurements you're trying to get. All right, so we got rid of some important constraints from those boxes that we had drawn out, but we're not gonna worry about those, okay? We're just gonna draw us a new box, and we're gonna get rid of those old lines, okay? Now to go back to what should have been that center line somewhere in there. Right there should have been the center line, but I don't believe that's the center line. Another option too is to draw a center line on this side and then come up from there. So yes, it was giving us a center line that was off center of this line here for some reason. I don't know why it does that sometimes, but you know, it is what it is, man. We're gonna keep pushing though. I think we're off to a good start with this design here. So that box there. Take it to the bottom. That's exactly how it's supposed to look. That's what we want. Now we did it for just this right here, but also we need to do it for the rest of the holes. So the holes, same difference. Once we get one hole mapped out and measured up, we can convert them over both sides. It just cuts down on the time that you spend in this program doing this. It could take your time. You get your measurements right, and then you don't have to worry about coming back to it. But if you rush it, then you're gonna have some problems. So 1.19 is what I'm looking at based off of center hole. Right. The way that we want to do this is from the edge of this servo. I'm not going to measure those holes off of the old frames. I'm just going to keep it consistent with this here. But if we measure up center hole from the base, we're at 1.165. So if we're measuring from this bottom plate part here, we're going up 1.65, right? So what we would do is get rid of the center lines that we have here so we can actually see. Right, so we get rid of that center line. Then we'll come up 1.6 and then we'll go across from there. So from that point, 0.165 locks us in there. And then we'll come over from there. And this will, whatever that distance is from our center point, that's what we'll put in there. There's a few ways to do this too. So technically we can measure from hole to hole center, and then we can divide it in half. That would give us the line for that right there. Or we can measure one hole at a time. It just depends on what your preference is, how your workflow is. It will go faster if you measure from center hole to center hole and then convert it over from there. So if we go center hole to center hole, we're looking at about 0.358 or 385, I mean. So 0.385, we'll take it and divide it, right? 0.385 divided by 2 gives us a 0.1925. So at a 0.1925 from the center point, we can get our distance from hole to hole. 0.1925. Oh, I did it again. 0.1925 locks us in right there. So that's our center hole. Now from this point, we draw our hole. We should be able to convert this hole to mirror this hole from this side to this side, and then measure both holes, or select both holes and then mirror them downward, and then we'll be done with those two holes for now. But also we want to do that. We want to do the countersink holes as well. The countersink holes are going to be the same as the other countersink holes that we had before, and we can just click on those to get reference points rather than having to remeasure those. But I think that we're sitting at a 0.3 as far as those countersink holes. For these holes here, we're going to do 0.13 because we don't want them to be snug on the screw. We want the screw to go right through the hole. And because the average M3 screw hole is like a 0.12, 0.115. Okay, so taking it up to a 0.13 gives it that wiggle room to where it just fits right through the hole, no hassle. Okay, so that's our hole. Then we're gonna have to do a countersink hole as well. Um, which is I think what we're saying 0.15 was for the countersink holes. Let's see. Let's select. Oh no, we on the other side. We gotta switch sides so we can look at what that countersink hole is. Countersink hole is 0.23. All right, so I was off. I was way off. I was at 0.15. We should have been at 0.23. All right, but that's the difference of just double checking and just throwing a number out there off the top of your head. 2.3 gives us that much right there. 0.23. Right. So now that we got those two, we can select those two. We can mirror and hit our center line here. It just gives us our circle there. We have those two there. The measure, select them all, and then mirror again, and then go and select our center point there, which would give us. Why is this off? Like, why is this so off? I don't know what's going on here. If I'm twiddling that off based off of the center line here, why is this going like something's going on crazy here? I don't know what it is. But we're based off of the center line here. Unless this bottom portion is not the same size as this top portion here. And I think that's what's happening here. I swear it'd be the slightest thing that throws you off and you'll think that you're wrong. So I can take a measurement from there. That's a 0.3. And then this. Let me see what the distance between this and that is. 0.255. That's what the difference is. So we're missing a 0.055. Well, 0.045. Let's see. Oh, you know what though? That's why that happened. We didn't measure these out from, so let's finish this out. We didn't measure these out from the holes in the beginning because we used the other bracket that I created to get the whole length of this. And that's what happened. Yeah, that 1.865. Okay, so that's what threw me off on in the long run because I was skimming and cutting corners in the beginning. So that's what happened, y'all. That's why those holes wasn't lining up right. But we're gonna get it. We're gonna get this together. We're gonna extrude this down. I think we needed point 0.45, 0.045. Puts us in the ball game, I think. Let's look at it again. If that wasn't it, then we got like a 0.05 left. Yeah, that was it. Yep. All right. So we got our little notch there. We got the whole surfaces with our thing measured out. Okay. Now, I mean, this is bare minimum work that you're gonna do when designing these type of parts. The idea is just to be optimistic about the measurements and just know that you're going to miss some measurements, or you're going to, accidentally create a hole somewhere that it shouldn't be, and you're gonna go back and have to fix it later. And just don't beat yourself up when that happens. So we got that, and double cutting both sides like we always do. Make sure that hole goes all the way through there the way it's supposed to. And then bring that picture back up. We're gonna countersink our holes for, I think, what was measure from that base to that right there, 0.13. We're gonna push these in a 0.13. That extrude inward, negative 0.13. Gives us a nice little shelf for our screws to fit down inside. And now we have this sink part right here for this little lip that they created on this thing. I guess we could probably put that at a 0.13 too. Or 0.1. Let's do a 0.11. Sometimes that won't be enough for the printer to create that space for you, because sometimes your 0.1 is what a one layer would be, the thickness of one layer. Extrude negative 0.11 gives us that space in there. Now we have that space in there where it can flush mount. The thing with making this identical to the other side is that if we come to that point where this doesn't work out for us, we can always flip this around to where these holes will be on the opposite side, and we can still get the same, we'll be able to still mount it properly. And how we do that is by when we make our hole mounts for this portion here, we'll make this down the center. So instead of me making a bracket that comes off L shape to this side here to have the two holes here, I'll make a T right here. Creating that T right there will cause you to have some issues, like as far as printing, but also it will give you an option to utilize both sides of that bracket. But also on the flap side too, it doesn't necessarily have to be um, mounted on the top. You can mount to the side. I can have screws that come in through the side here. But that's just something to think about. Sometimes you just gotta understand, like, oh, like I just caught this. I just caught this. My countersinking holes is on the wrong side of what I just did. Okay. And it's all right. If you catch it, it's all right. And I caught it. So it's all right. All right. So what we're going to do now is I have to take these holes to the opposite side. All right. So the extrude that we just did on the, nope, not that one, this one's. We got to unextrude these. All right. Take them away. Delete. These holes have these in, you know, what do you call them? Countersink holes have to be on the opposite side of this. So how do we do that? Well, we have to, there's so many ways to do it. We're going to focus on the two-sided extrude, which is going to allow us to start from the surface on one of the extrudes and then cut into it on another. Right, so when I extrude this, I'll select two sides. This topper side here would be strictly on that side there, which will give us that whole play. And then this side here will lessen the number until we get to our point 13. That's what we have. Right? And it'll cut it from the 13 of the other side and not necessarily from this side here. Well, actually it's doing that anyway. Let me see. So 0.3, 0.17. All right, so we're gonna have to make this number a 0.17 in order to get that that 0.13 that I was talking about. And that's just quick math. I don't think that I made a mistake here, but sometimes you can make a mistake with the math. All right. So we no longer have the hole on that side. It's on this side. And let's see if I did my math right. Hopefully I didn't let y'all down. I did it right. 0.13. All right. And all I did was I cut the difference in half. 0.13 plus 0.17 is 0.3. Quick math. But my math ain't always that quick. I want y'all to understand this. When you're thinking about designs, it doesn't always math for you. All right, so let's get rid of that sketch. This is how it would normally look like coming off of here. If you wanted to print this flat, because that's probably the best way to print these, is to print them flat, is to just pick a side and stick to it. And then if it doesn't work out for you, you just go back and print it another way, you know. Kind of like how I do most of the time, you know. Most of the time I make a bunch of prints, and there's nothing wrong with that, but sometimes, man, it's just like it doesn't benefit you to have to print a bunch of times, waste a bunch of filament. We're going to, this is that part I was talking about that we're just gonna do, you know. It's not planned, but we're just going to do it. I want to be able to put this wherever I want it. And with this being a rounded edge here, we can't really get to that portion. So what I'm going to do is extrude this edge back and join it, right? What that's going to give us is, what we got? Where's that servo body at? I'm curious as to where that body is. Is it on the top side? All right, so we have the wheels. Oh, it's attached to the frame. All right, so what we're going to do is split this off of that body first. Because that happened. That happened right there. Um, um all of this got connected together. I okie doke to myself, y'all. All right, look, so the frame, so this gotta get split. Oh my gosh. Yep, that gotta get split. Uh, this is the top swing arm. Yep, when you get designing and you forget to remove or make the parts invisible, you end up with those parts that you gotta go back and undo, you know. You gotta cut them off. And, yeah. So cut this surface here. Pick that surface there. Split it. Bam. Now we're going to hide this one. All right, hide those two. These two are going to get merged together. So one. Okay. And then this one and this one are going to get merged. Not all of them. Just that one and that one. Merged to one body. This will be the servo mount. Okay, servo mount, or should I say front mount? And then going back to the frame, we have to stick that back together. There. All right, so now we got this back where we need to have it. We joined some parts together that shouldn't have been joined together. But what I'm gonna do as far as creating that lip for us to mount to for the servo mount is I'm going to extrude this back, and I'm going to join the extrude rather than cut these parts, right? We're going to create a base here. So we're going to join it, we went back 3. We can pull up the servo to see where it falls. We don't necessarily need to go that far back, but something to consider. Maybe there. Just matters what type of thickness we want to carry out with the rail. Maybe a 0.9. Maybe we can go 0.9 on that. So we can start off from here to line it directly up with that surface there. Hide that surface, hide the servo again so we don't join it again. And then from there, we can extrude out whatever that length was of 0.9. We can extrude out 0.9 from there, right? And then if we want to take this thickness down, we can take this thickness down. All a part of designing. I can pull this and then it'll melt into that side rather than. Okay. All right. So aesthetically, this is going to be all right. Having this amount available will give us a good lip to make this sturdy for the rest of the servo weight that's going to be hanging off on this back side here, because the servo from this point is going to be sticking out 0.118 or 1.18, 1.15. Okay, about 1.15. So we're compensating for that, whatever that distance is that servo is going to be sticking out. That's just going to give us the sturdiness of holding that weight. So our mount here is going to curve off and come back. There's going to be a screw here and then a screw back here somewhere to secure this bracket onto the frame. That would be, that's like my way of doing it. Sometimes we can space this over so we can get a round edge here, so that that corner that we're gonna bite into doesn't interfere with what we're doing here. Because let me see. Let's do this. So we'll go this route. Let's extrude this to the surface here and create a new body. So now this body is overlapping that body there. And then we'll come and we'll cut this back to that. We'll hide the frames. And we'll join this here. Join it back to this. That, cut that back, right there. All right. What I was saying is that the edge of this corner here will be kind of brittle if we leave it like this, you know. But we know this will be a perfect fit for the servo to sit down in and mount here. Sometimes what I would do is push the servo to the side, like push the whole thing over to the left and cut like a L shape into the framework here. So this kind of hugs the side of the frame. Whenever I do that overlap, usually that overlap is anywhere from a 0.2 to a 0.3 overlap. And this just stops it from moving left and right. That's just extra strength and durability if you want to do it that way. We don't necessarily have to do it that way. We can put our holes at the top of here. There doesn't have to be a specific measurement for those holes either. We can just go from the top and drop our holes in. Our mounting points will be good to go. On this bottom side here, we would rework these frame areas if you feel that this is a more wasted material than needed to be. We can cut this up more and round this off to be a little more tailored and high cut. But also this could be chamfered out as well. Like all of these design factors are, you know, something to consider. But as far as it being in this, looking like the way it is now, this gives us a good headspace to see exactly where it fits with the body. I think we're still in a good headspace here. We're in a really good space. See, those servos are gonna sit in there nicely. This right here is just it's not part of the design, it's just how it turned out inside of the software. But we have enough room for the servo to sit here. And if not, we still could mount from the back side. And in that case, we would just have to cut and flip this portion here. But that would be two options that we can just have inside of the CAD software, inside of the STL file, I mean, for whether they want to mount front or mount back. You know, that's an option. As far as where we sit now, we have a solid area to have everything positioned where we needed to be positioned. We have our servo above that mounting point that we were talking about for that upper swing arm. Where is it? Top swing arm, right? Our servo horn is going to be up here above that point. Because it is above that point, it's going to stick out on the side here. The swing arm mounting point is something that we'll have to consider putting inside of the servo mount right here. Now remember, I was talking about this space that we have in between because we're at the center point, and we needed to figure out how we can mount this upper swing arm, you know, without having problems and running into issues with it bumping into the servo horn. Well, we got our solution here. because we have this sidebar, we can actually extend out a little more. We can create a lip for this to mount to. So we can have that portion right off of the idea that the servo is going to be in that spot too. So we don't have to worry about this running or hitting anything. The servo horn will come out. Will sit out about this area, about this much here. Is where the back end of that servo mount will sit out. The front end of it will probably land us around about here. We'll have about a 0.2 gap between where that servo horn will mount with the top of the spring. So we'll possibly have like a spacer in between there to help us out with that. Usually I'll use like a nut in between to give me that distance. But I mean, it all comes into play that we're in the ballpark of where we really want to be. We're at a 0.38 coming off of from the flat surface to that clearance. This horn that I have right here, coming off of that front side edge, we're sitting at 0.26, and this isn't the original horn that we're going to use. Is going to be a little bit thicker than this, but so we will be in a good space for this all to come together and work for us. I'm kind of excited how this came together, because it's a matter of just understanding that certain parts aren't going to get completed until you have other parts to kind of like help you get to that point. So this, from this to this, I think we was at a 0.3. Yep, 0.3. So in order to make this work, what we'll do, what we could do a circle based off of that circle. That's what I'm thinking. So let's go here. Our frame. We can draw off of the top of this, right? Let's get us a drawing. We're going to draw on top of this. We're going to project this circle here. Yep, just that circle. Hit the OK button. So now we got a projection of that circle, right? We're going to create some space based off of that circle to give us, this feel here. So what I will do is just go from, we'll take this whole space. This whole space will give us, it'll give us more than enough to work with, right? So what I'll do is we'll finish this picture here. We'll take, we gotta wait on it now. 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 Oh, there we go. We'll take the swing arm away, and we'll take the frame away, so we don't end up making that same mistake that we did before. All right. So now we want to extrude this part here. So we're gonna do the whole circle. I'm gonna do the whole circle, okay? Extrude to this side here. It wants to cut it out, but we don't want that. We want to join it. Okay. We'll go back to this side, bring our sketch back up. Go here where that hole was. We're gonna use both sides of that hole. Even though we have that space, if we just cut that surface, we'll end up with that fine line that I'm telling you about, that phantom line that'll show up in your print. and then we'll extrude this out to the surface here or past it. We can go double-sided or simultaneous, and then we'll just drag it until we go through both sides. The best way to cut holes, in my opinion, because it guarantees you a clean cut. All right, so we have this hole set out right here. That swing arm is going to be pressed with a fit. It's going to be pressed, if I'm not mistaken. Let me see. Let me look at that thing again. We would have to. Yeah, we wouldn't be able. We will have to put the heat insert, brass insert on this part here, and then have our bolt on this side. If we do it any other way, it won't help us. You know. Then we'll go back to our 0.23, right? Come over here. 0.23. Go back to our sketch. Draw in a 0.23. 0.23. Finish the sketch. And, press our thing down. I think we were at a 0.13 as far as our inset. In this case, it's going to be negative 0.23 or 0.13. Sorry about that, y'all. Okay, so we have our area where things look nicely put together. If we want to sturdy out this hole, we do like we did before. We'll take the two edges, and this don't necessarily have to be done for this because it's already a sturdy hole, but we can always do a fillet and round it out. It just makes it look more smooth, more clean. Makes it look a lot more clean and professional. But also, like I was saying, this portion, like doing this here to that angle there, gives it more strength as well. Anytime you have a 45-degree bend in a part, there's always a chance that it could break or snap, because that 90-degree is kind of like a tear in the, it's kind of like a fold in the paper, is going to have that easy break point to it. So how we get rid of that is we round those edges off. But also keep in mind, don't round too many of your edges off in the beginning of your designing, because when you have to move things around or undo stuff, this becomes a hassle to fix parts and dimensions. When you have a bend like this, it makes it a whole lot harder to work with. But this is how the mount is going to turn out. This mount is going to be printed flat from this side here. There's going to be like some little support things that get printed inside those holes on these sides. So you have to consider those as well when you're doing your stuff, that those are going to happen. These side mounts here, they can come out a bit rigid, depending on what settings you have your fans on when you're printing. So you kind of want that cool, slow rather than cooled fast, so you can get a good melting point on this area here, so it doesn't be brittle and break off. And I'm dealing with like ABS. I've been printing these parts with ABS for a while now, um, which works pretty good for the durability and like that, like the I guess like the bend radius that they have, like for spring action, they don't snap as bad as PLA does. But I mean, also if you got like something like nylon, you don't have to worry about these edges with nylon because nylon is a whole nother beast. It's kind of hard to break nylon once it once you got it placed, got it in place. Man, it does what it's supposed to do. All right, so we are there with it. We still have to make that hole for that upper swing arm to be pressed in. So now, on the flop side though, this side of the mount, it still has to be mounted to something. Okay. Now, in my opinion, I would rather see this mounted to the frame. So we go back to the frame. Um, I would like to see this mounted to the frame somehow, and not just to have like a screw that's coming straight through this. Because remember, we want this area open. We want the center area open for that spring to come down here. So we don't want a bolt to come straight through this hole here. So we have to make a mount that's going to come from this part here and not interfere with any of that area, like any of this cutout area. We want this to be open strategically for that spring. So designing like just a small bracket that comes off here and that goes up to the top side is the next thing that we will do. I mean, but we can do either way though. We could have um no, that would be the best way. Yeah. Unless y'all got any options or opinions about how this thing should come together, that would be kind of dope to if y'all chimed in what y'all like to see. But where I'm at with it, I'm thinking simple bracket coming off of this the front of this frame right here, just to come down and give that stability. But also in these applications, like 3-point contact is like key. It really is key. So maybe or this frame, it can have that part coming off of it naturally. It doesn't necessarily have to be an add-on part. It can just be a part that's there. Let's see how we will spin that though. Maybe it'll be a half circle that comes off like this, and it'll be part of the frame. So when it's printing, it will print off at that crazy arch. Yeah, that might actually work. Let's see. Let's do that and see if that is beneficial. So what I'll do is we'll draw based off of this frame, off of this surface here, and then let's save this for a quick second. I forget to save sometimes. Sometimes it will crash on you if you don't save it, and all your work will be gone. All right, so off this surface here, we can get us a nice start. And I probably want to match this outer portion here and have that circle to carry on till it gets up here or down here to where this is. So, you know, the thing about this is how do you want your parts to fall in together, whether you want them to be secured to this or or to be a part of the frame, because we can do it either way. Um, let's see here. So it's coming from that center line, and then oh no, let's get it from this line here. Let's draw some center lines. When in doubt, draw a center line. Right? Come on. So we draw a center line that comes up here from here. Right? I kind of feel like this ain't gonna be the same as this. Like it's gonna land us higher somehow. And if that's the case, maybe we could just make an attachment that will hug the frame and then, you know, come down. All right, we got a center line. Let's see what this does. Put a circle. Put that center point there. Draw the circle. Yep, exactly. It's exactly as I expected. Okay. So it's not going to be particularly. So let's go from this point then up to the top side here. That way we can get us a flat start up here. Right. And I mean, we can move this stuff around. It doesn't necessarily have to be, um, it doesn't have to be set in stone what we're doing here. We can always go back and, you know, create a different perspective of how we want these done. See that right there, there. And then maybe have another circle that comes down that meets us around about here. Come right there and then down. Or maybe I'll do it just like this, you know. Down here, and then whatever this is here. Circle there down to that point there. All right, let's do some trimming and then let's see what we're coming up with. So we got this. Like that. Undo that. I thought I had. And gonna go to that one. We need that to be a 90. Right. And then from here to here, I think we can make this square for now and then just chamfer it or fill it later to get that extra whatever going on. Yeah. All right, so let's finish. Or no, we got a little more work to do here. Let's cut this edge here and cut this circle here. All right. Now I think we're ready. All right, so let's do this. Come over here. This whole surface here. Say extrude 0.3 to match the framework that we already have. We'll get rid of the swing arm and the frame so that doesn't become a part. I mean, also we could always do new body instead of taking those views away. But it just helps me mentally to see what I want to see. But yeah, so swing arm coming from down off of this, like this is something like what I would like to see as far as a bracket be created that will hold that swing arm. And it doesn't have to be this meticulous in a sense. You know, in some cases it could be overkill, but it depends on the designer, really. It does. Like that portion there, it doesn't have to necessarily come all the way down through the whole thing. It could just be a little lip that creates that space that you need to make that happen. We did it again. Let's undo that. We don't want to join these bodies together. We don't want that at all. So let's undo those for now. Is at -25. We would chamfer or fillet this area here. Create that structure. See what I was talking about with those lines? See how that line created that issue right there where it just makes a bend? Exactly what I talk about, like when I say those phantom surfaces, they just come out of nowhere on you. And then the only way to really get rid of it is to you gotta fandangle your way around in there. You extend out a little bit, grab an edge, cut that surface, and get rid of that extra body. Remove that body right there. join the two surfaces back together. But see, the like little stuff like that, you know, it causes you time and you know, wastes your attention because you'll be thinking about moving somewhere else with the design, and then you get blindsided with something like that. All right, so for this right here, this piece is pretty thick. I think overall we'll end up doing some work around a way to work around this and get it to where it's not as bulky as what we see here right now. All right. Yeah, it's a pretty bulky piece right now. The idea is to just get it drawn up to where it's gonna fit. There's this piece here that's eating into the frame. So take that and we'll be extruding that to where the frame is, right? Like that. And then we will have that cut back and out the way. Yep. But now that makes it a 0.29 rather than a 3. Sometimes there'll be some weird things going on. Maybe it's not all the way flat. That could mean. All right. So I wouldn't technically want to print this part as connected to the servo mount either, unless you want to sit that long and watch the part be printed in that type of frame, you know, like those type of time limits, you know, like it's time consuming to print a part like this together. Like say I had a bar that connected this whole thing together. That part is going to take a long time to print. That's why I went with the route of possibly just having one arm that comes off for the front side of that mount. Even if we print it to where it's already part of the frame, we'll deal with the same. We'll have to wait for the frame to print this, which it won't be a hard thing to see. It just comes down to the structural integrity of a piece like this and what this would be used for. Is holding up this part, you know, with all that torque and all of the tension that part is going to have on it. You would want this part to be printed flat rather than upright with the layers being vertical to that pull. You want those layers to be flat on the pull. Like where the bolts are, you got to shoot for the bolt sandwiching the layers together rather than the hole going down the center of the layers, because that brings apart the layers. It pulls against the layers rather than sandwiching the layers and being a more sturdy part. So that's why I'm looking at this in the sense of having multiple pieces. I thought we was gonna get to the back today, but Man, we put a lot of work in on this today already. So I think this is probably a good stopping point for today. Also, we're almost at 3 hours on this video. Um, and we kind of want to just keep up with, what's going on. I mean, now that we have the servo portion kind of set, we can push this rod here, we can push this back. Or we can cut it. I mean, we have our servo areas pretty set and ready to do, There we go. So we'll cut it back to the servo, the width of the servo for now, just so we can kind of see all of the stuff we did just recently. All right, we didn't want to do that though. We don't want to cut through the knuckles. I think like sometimes this keeping in mind how these things behave, well, it's gonna play a huge part in how you maneuver around this platform. Let's see, front mount, which is gonna be gone now. That part goes away, right? Or should I say the top half goes away. The bottom half would possibly be attached to the bottom servo, the mount. That's something that we have to look at too. When we're dealing with this. So that might be a possibility too. This could be a all-in-one plug-and-play type ordeal as far as this servo mount. Doing the same thing that we did to this hole up here and having it come down here for this servo, for this bottom swing arm, would be like a really dope setup as far as it being on one piece. Having all the linkages set to the servo mount, and just being able to build the servo mount up to withstand that type of pressure. It's kind of cool to think about, because there's different directions we can go with it. We also could have had the servo mount to break off from here and secure the outside here as well. We could have did that. But for the base, we don't necessarily have to do that, because the base, we're not gonna have to have this area open to compensate for the spring. We only need that top side open. So with this one being open the way it is, not necessarily needing to be open all the way, we can go straight through this bolt for the bottom side. But also, I mean, we can continue this bracket straight down as well, which would give us a lot more sturdiness for keeping them aligned. So that's something to think about, how this all comes together. I think we did pretty good today. We did pretty good today. We have these pieces set in here. We can bring the body back in and see how these would come together. And let me see. Come on, don't think about it, just do it. All right, let's get to it. So where we sitting at right now, no wheel from the front view, looking good. from the side view, still looking good. We still have we have that clearance right there with the hood. All of our screws are going to be inset, so countersunk holes, so we don't have to worry about touching the top of this hood at all. This is going to lay in here pretty nicely. I think I think tomorrow we'll design, we'll just do a mock-up spring, so we can kind of see where that spring is going to set, and maybe do a mock-up servo as well, so we can see where that servo horn is going to lay in here. But preferably the servo horn is gonna end around here, around that, within that 0.3 area range, and we'll see that space that we have to create a link to for that servo horn to mount to the spring. But we'll see that tomorrow. I think that's where we'll go. And if you're in here tomorrow, please remind me, so that you know, that's where we'll start. But she's coming along nicely. This is going to be a crazy hopper. The actuation is going to be crazy, and we're gonna be able to get a full extent out from here. That's gonna be dope. Our range is probably gonna be from up here though. Like that servo swing arm is gonna have to come in from the top side and then swing down to bottom about here. We won't be able to get a full turn, a full half turn out of that servo, but hopefully we don't need to. Hopefully we can go with a shorter servo horn, and we don't have to take it up that high. You know, we can come in at halfway, and then a quarter turn will get us to full ride height. But we'll see. We'll see what happens tomorrow as we design these a little further. But thanks for watching. If you like what you see, like, subscribe, share the video, share the channel, you know, hit the bell in case you want to come back for when I go live again. You know, all is appreciated. You know, jump in the comments as well. You know, show the algorithms that it's the type of stuff that y'all want to see, and they'll keep on referring things like that. And then maybe this will be a spin-off, and other channels will be created to, you know, jump on board and give y'all content and material like this, where you're actually seeing things designed in real time. But until next time, y'all hold ourselves together, you know, keep creating.